1.5. It follows along the same lines as this. Now, if I ask you to find the sum of this sequence right here, okay, what I need you to do is you can add them as is. That's okay. And you're welcome to do that. Or, I have to count the number of terms. 1, 2, 3, 4, 5, 6 terms. And I want to find the sum of the 6 terms. Okay? So, looking up here, these are my geometric ones right here, this guy and this guy. I can use this one because I do know what the 6th term is. I can use this one because I know what T1 is and I can figure out what R is. So I start by going T to the 1 is 1, R is 2, okay? T to the 6th, which is the term I want, is 32. So when I do that, I take my R value, which is 2, I multiply it by my T to the n, which is 32, I subtract 1 over 2 minus 1, which is equal to. So what is the sum of the first 6 terms of this sequence? 63. There's all 1.4. You're welcome. Okay. So that was yesterday's work. Now, we call this a finite amount of terms, meaning I know where the last term is. Okay? And that my value is going to be, my sum is going to be an actual value. All right? What we're going to look at today is what happens if our ratio, so this is if this works, if and only if our ratio is, just a second here, I want to make sure I write this right. Ratio is greater than 1 or our ratio is less than -1. Okay, now what that means is that my ratio will be a whole number greater than 1 or a value, any value greater than 1 or any value less than -1. So what am I eliminating out of this? What's in between there? 0 and fractions. Agreed? So what happens if my ratio is a fraction? So let's take a look at a possible sequence then. Let's start at 64. And let's say that my ratio was 1/2. Okay? So what's my next number in the sequence? Keep going, Brittany. Yeah? 8, 4, 2, 1, half, and then it can keep going, right? So as I add these up, let's take a look at it. Let me just cut this off a bit. I'm going to start here, just to make it a little easier. Okay, as I add these up each time. So the sum of the first term is 16. What's the sum of the first 2 terms? 24. Sum of the first 3 terms? 28. Sum of the first 4 terms? 30. Keep going. 31. 31.5. 31.75. S to the 8 would be 31.875. And I would keep going. All right. What do you notice about my sums?
They get greater as you keep going?
They continue to get greater, yes. But what happens as I get into the fraction part of this?
They stop growing as much.
As much, that's exactly right. They stop getting larger by large numbers. So what's happening here is these values are going to continue, but the amounts they go up by are going to be smaller and smaller and smaller. So, is there a number that this sequence is going to approach towards, but maybe not quite get to? Is there going to be a maximum value that it'll come closer to, but not get to? Does anybody want to take a stab at it? What do you think it is? What number is this going to continue to get closer and closer to, but not actually get there? What is it? Yes. That's exactly right. What she said? Good. 32. Okay? 32 is right. Now, we call this an infinite geometric series, meaning it goes forever. Now, in order for something to be an infinite geometric series, my ratio has to be between -1 and +1, meaning it needs to be a fraction value. Okay, or a decimal value. So, to get what the term is, we call this a converging sequence. A converging sequence. That means that my sums are going to converge on a number. So if your ratio is between -1 and 1, if my ratio is between -1 and 1, I'm going to have a converging sequence. So now I can find out what that sum is by taking the sum of the infinity is equal to t to the 1, which in this case is 16, right? Over 1 minus my ratio, which was 1/2. So I have 16 over 1/2. What's 16 over 1/2? Works out to what Shay said, 32. So that value, if I kept this sequence going, the sum would get closer and closer to 32, but it would never actually get there, because my value is just getting smaller and smaller and smaller. So it approaches it. Okay? So the last step in all of this process, in all of this here we've got arithmetic, 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 geometric, 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 geometric to an infinite value. Okay? These are finite values, meaning I know the exact term that we're going to stop at. It's going to stop at a certain term. These two. This guy, I'm saying that this is going to go forever. Now you could have a converging one, or you could have a diverging one, meaning the value, the ratio could be larger and it could go forever, but it's not going to converge on an actual value like this is. In order for it to come, in order to use this, my ratio has to be a fraction. Positive or negative has to be a fraction in order for this to happen. Okay? Questions about that? Let's look at two examples. All right. A, 0.5 minus 1 plus 2 minus 4. What is my first term? 0.5. What is my common ratio?
5 minus 2.
Minus 2. Okay, so far so good. Decide whether the infinite geometric series is convergent or divergent. State the sum of the series if it exists. Is this going to converge or diverge? Meaning go away or get larger. That's what divergent means. It's divergent. How do I know it's divergent? I'm multiplying by -2. But in order for it to be convergent, the ratio has to fit in there. That's the only way you can have a converging series, is if your ratio is between -1 and 1. Okay? Okay so far? All right? What about the next one? 12, 3, 3/4, 3/16. What is t to the 1?
5. Oh, t to the 1 is 12.
T to the 1 is 12. What is my ratio?
4.
So what does that make the ratio?
Quarter.
We're always multiplying, we're not dividing. So you have to, if it is divide, then you multiply by the fraction. Okay? So we have that. Is this convergent or divergent? Pardon me?
Convergent.
Convergent because it falls between -1 and 1. So let's find out what it is. Equals 12 over 1 minus a quarter. 12 over 3/4. 12 times 4 over 3. 16.
Did you not just go 12 divided by 0.75?
If I had a calculator, maybe I would. If I want to do mental math, I would do it my way. Can you do 12 divided by 0.75?
Yeah,
Okay. Better have your calculator.
there we go.
Okay. Take a look at the terms, please. What's the sum of the first term in that sequence in B? 12. What's the sum of the first two? 15 and then
15.75.
15.75, right? And then it would continue to get smaller and smaller, but it would continue to approach 16. Does everybody make sense of that? So that's, as my series goes, that's where it ends up. Is this going to get a sum closer to 16? Okay, questions so far about that?
How many do we need to use in 1.5?
Yep. Yep. So in 1.5, all you have to do is determine whether the ratio is between -1 and 1. And if it is, use this guy. If it's not, you use whatever you used in 1.4. One of those two. Yeah, go ahead.
In each question, will it tell you like what kind of equation to use? Like for this one, it says infinite geometric series. Will it say that for each question or not really?
No.
You just kind of have to know.
Well, how do you figure it out?
Well, you get all your factors and then you see which ones apply. Obviously.
How do you figure it out?
Like you get like your T1 and your R or whatever it is, and then you see what you need to find, and then you see which equation relates to that.
Yeah, but what is your question that you're asking me? Do I know whether or not, how to identify whether it's geometric or if it's arithmetic?
No, I was just saying, I was just asking, will it always give you the equation, like what equation to use, or do you just have to figure it out yourself? Like it's not that hard to figure it out yourself.
Well, you have two choices.
Yeah.
3, if you include this. If it's an infinite converging one, meaning your ratio is a fraction, you use this guy. If the ratio is greater than 1, or smaller than -1, you use one of these two, whichever one you want. If you know what the nth term is, then you use this one. If you don't, then you use that guy. So you basically process of elimination as to which one you use.
Yeah.
All right? Okay, let's look at this example 2 on 43. In the first month, an oil well Manitoba produced 36,000 barrels of crude oil. For each month after that, it produced 95% of the previous month's production. Okay, so T to the 1 starts with 36,000 barrels. My ratio is 0.95. Is that going to be a convergent or a divergent one?
Convergent.
Which one?
Convergent.
How come?
Because it's less than 1.
Because it's between 0 and 1. So it's convergent. It means that there's going to be a value that the sum is going to come closer to, but not actually get there. Okay, write the series of terms that represents this. All right, use your calculators then. Give me the first 4 terms. So 36,000 times 0.95.
34,200.
Okay, times 0.95.
32,490.
Yep.
30,865.5. 25.
Okay, good, thanks. Okay, so there's your first 4 terms. Multiply each term by 0.95, right? Sorry, I lost my train of thought. If this trend continues, what will be the lifetime production of this well? So now, is there a value then that it's going to converge on? the amount of barrels that it's going to converge on? Yes, there is. We know that because your R is a fraction. It's between 0 and 1. So now let's find out what that value is. So we go, oops. Let's try that again. There, S to infinity. Okay, 36,000. 1 minus 0.95. 36,000, 1 minus 0.95. So 36,000 divided by 0.05, and we'll get the amount of barrels that it will produce.
720,000.
So over time, we'll get up to 720,000 barrels of oil. Okay? Again, how did I know that it was an infinite one?
In between -1 and 1.
In between -1 and 1. That's right. I'm going to leave working example 3 until tomorrow. 4 is fine, but 3 is has to do with repetition of numbers and how to write them as a fraction. So we'll worry about that tomorrow. Okay. Now, here's what I want to look at right now. Go to page 50. Okay, we have to finish 1.5, but what I want to do is I want to kind of go through 1.1 to 1.4 again. Just a quick overhaul as to what is expected of you. So in 1 to 1 and 1.2. 1.1 is just this guy. That's all you're working with. 1.2 works with this guy and these two. 1.3 works with this guy. 1.4 is this guy with these two. And 1.5 is the collection of those guys. So, examples of questions. Find out which one's an arithmetic sequence. How do I know it's an arithmetic sequence?
You add
You add to get
the same value, but a different value, but the same difference.
from one term to the next. What is that value called?
Sequence or
No.
series?
What's the value that we add? What's that called?
D.
What's the D called?
Difference.
Common difference. Okay? So in arithmetic, you got to find that common difference. Okay? Determine the number of terms. So go to 4. 4 is the part that, well, 3 and 4. Let's start with 3. T to the 8 is 25. T to the 5 is 16. Okay? So there's two ways in which we can do this. The first way is to just put blanks and figure out how many times I have to add to get from one to the next. But I don't want to do it that way. I'm going to do it a little bit longer way. So I'm going to write this out. My general term, t to the n equals t to the 1 plus n minus 1 times d, right here. Okay? So t to the 8 is 25. So I have that. T to the 5 is 16. And I need to find out what my common difference is and what my t to the 1 is. Now, because I'm adding to get from one to the other, what do I do here in order to solve this? I could multiply one of them by -1. I'm going to multiply the second one by -1. So I'm just going to change all of these signs. Now, when I add them together, which value is going to disappear?
T1.
T1. That's right. So 25 subtract 16, 9. T1 subtract T1 is 0. 7 subtract 4, 3 equals. 3 equals D. Now I have my common ratio. That's as difficult as it gets, basically, in that first section. Now I have my common ratio. I want to find out what t to the 1 is. So I go 25 is equal to t to the 1 plus 7 times 3. 7 times 3 is
21.
21. 21 from 25 is? Thank you. 4. Okay. So now I could figure out the rest of the terms. It would tell you to say, okay, find out 3 more terms for this. So there's the extent of it.
I'm sorry. How did you get like the 7 and 4?
Here and here.
Yeah.
N minus 1. So that was the 8th term.
Okay.
8 subtract 1 is 7. And that was the 5th term. So 5 subtract 1. That's a good question. Okay. Everybody following?
But you could have plugged in the 3 for the 16 as well.
Yeah.
It
And
doesn't matter what term.
and then
you
check
use.
your answer. Make sure it works. All right, now what I would do is I would take that, 16 equals t to the 1, which is 4, plus 4 times 3. Do they equal? 4 times 3 is 12. 12 plus 4 is 16. I got the answer right. You can check it. I guarantee you got it right. Okay? So far, so good? All right, now the second thing that in that first section is what happens if you're given a value. So for example, I'm given 129 as my nth term. I see that t to the 1 is 3. So I've got 3 plus n minus 1, and what's my common ratio?
2.
2. So now I need to find n. That's what there's the second thing that's difficult in this section.
Can you just subtract 3?
Subtract 3, 126,
Divide by 2.
yeah, n minus 1 times 2, divide by 2,
63. And then add 1 to 64.
not very complicated. Yeah, Brendan?
It'd be wrong to like divide 129 by 2 and subtract 3, right? How do
Yeah.
you always have to,
Well, because then you'd have to divide the 3 by 2.
exactly. So do you just always like subtract stuff before you divide? It's easier that way.
That's the rules when you do algebra, when you're solving. Add and subtract first, multiply and divide last. Yeah. Right? Okay, so yeah. I mean, you can do it your way, but you're instantly into fractions there.
Yeah.
Okay, which you can still do. Alright, that was all 1.1. That was it. 1.2 dealt with the sum. So, can you find the sum of a arithmetic series? Let's find one in here. Let's look at, I'll do 7a. So I got t to the 1 is 2. Common difference is 5. And it wants the sum of each arithmetic sequence. So I need to find out which term 92 is. 7a. So I want to find out which term 92 is. So I use my original from 1.1. 92 equals 2 plus n minus 1 times 5. So what do I do first? No. Take away 2. 90 equals n plus 1, n subtract 1 times 5. Divide by 5, what do we get? 18 equals n minus 1. N equals 19. So I need the sum of the first 19 terms. Okay, so which one do you want to use?
And divided by 2.
Okay, so I'm going to go 19 divided by 2. I know t to the n, don't I? So let's use that one. So I've got t to the 1, which is 2, plus 92. Using this guy. That gets me the sum. So 94 times 8.5. Whatever that is. Yeah, 9.5, sorry. 93. There's 1.2 for you. Okay? We alright? Okay, I'll do 1, 3, and 1, 4 tomorrow. I want you to have a lot of time to work today. Are there any questions from yesterday that you want to do?
Yeah, did we get pre-tests in this class?
Yeah.
So like when the test will be.
What's today, Wednesday? Tuesday.
We'll get the pre-test Tuesday?
Well, the test will be Tuesday.
Why?
Test Tuesday.
Well, then you can write the math test Monday.
There's no school Monday.
And you're writing Tuesday. You can't give up any more days. You can write it Friday.
But what if we
If you're
like,
done
what if
1.5
we just-
today, you could write it Friday.
What if we just go on to 2.1 and we wrote the test Wednesday? Switch
No.
down the days.
Are we gonna get the pre-test tomorrow then?
I'll give it to you today.
Okay.
If you want it. I would focus on doing the review in your workbook because it's broken down by sections and each question that could possibly be asked are in those sections in the workbook.
You just take the
So,
question from the workbook on the test, or?
well, it's still out of a test bank, but yeah. All the styles of your questions will be out of here. Okay, so if you went through your review in your workbook, and you're fine, no worries for your test. Because it covers all of these right here.
Is this supposed to be a hard unit?
Yeah?
How much
Okay.
are we gonna use?
Okay, let's get going. Are there any questions from yesterday?
Question, like for all of those formulas, we need to like have them memorized or
No.
like a sheet.
You'll get a sheet. Any other questions today?
Okay, so I'm sure.
Yeah.
Both of you.
Have to pee.
So what? That's what your breaks are for, and so is lunch
Well,
hour.
I did. I
Half an
peed after
hour.
lunch.
Mhm. You can't hold it for an hour.
I've been taking lots of water.
That's excessive. 100 feet per hour.
Yeah. 3 if I have to. Okay.